If both 3 squared and negative 3 squared equal 9, why does the square root of 9 only equal 3? Most people say that's just a rule, but it's not that simple. In this video, I'll show you why we only take the positive root and when the negative root should also be used. It's all about definitions, graphs, and a little logic. So let's break it down. It's true, both 3 and negative 3 are square roots of 9. However, here's the key. By convention, the radical sign always tells us to find the principal root or the positive root. But this isn't to make math confusing. It's to make the square root a function. For each input, a function can only have one output. As you can see here, if we just use the positive roots, the function is fine. Each point only has one output. However, if we included the negative roots, then we would get this graph. As you can see now, for any x input over 0, there are 2 outputs for the square root of x, which means this is not a function. So by convention, when you see the square root with a radical sign, it really means take the positive root. Mathematically, this is the same as taking the absolute value of the root. Now, this may seem weird, but it also makes sense. For example, in real life, if we knew that a square had an area of 9 square units, to find the length of one of the sides, we take the principal root. There's no way one of the sides has a length of negative 3. Okay, so the principal root is always positive, and by convention, we take the principal root when we use a radical. But then, what about the negative root? Sometimes, when solving equations like quadratics, we need to take both roots. To isolate x in this example, we take the square root of both sides. And using our definition of square roots earlier, we know that we are now finding the absolute value of x, which has 2 solutions, both the positive and the negative roots. So in a quadratic, we take both positive and negative square roots. So to distinguish, if you're just taking the square root with a radical sign, we assume it's a function. Thus, we take the principal root or the positive root. But depending on the context, like solving quadratics, we may need to include both positive and negative roots. This ensures that we have all our answers. And that's the logic behind the principal root. At the end of the day, it's just like any other math symbol. It's all about how it's defined. If this video helped you or you learned something new, don't forget to like, subscribe, and share it with a friend. I've also compiled a bunch of resources that I highly recommend, which you can find down in the description. Now, keep working hard and keep learning. Thank you for watching.